Hello, welcome to another video on nodal analysis. Before we proceed to solving the problem, I would like to remind you to hit the like button, hit the subscribe button, hit the notification bell. In this problem, we are required to find the node voltages. So we have been given our reference node, and we are required to find the node voltage 1 and 2, because those are the two essential nodes that we have apart from the reference node. So in order to do that, we come to node 1. So we say at node 1, the current for this branch is, that's the current flowing out of this branch is minus 2 ampere, because it is not flowing out, it is flowing in. So minus 2 amperes. Then the current in this branch, since the reference node is 0, then we have V1 minus 0 divided by 2. So plus V1 minus 0 divided by 2. Then write the current in this branch. That will be V1 minus V2 divided by 10. And the current in this branch, since we do not know the current in this branch, we're giving it an arbitrary value of I. So let's call that plus I, since it's flowing out of the circuit, out of the node. Then we equate everything to 0 according to Kirchhoff's current law. Then we proceed to node 2. Then at node 2, okay, let's call this our first equation. And at node 2, so we have this current that is flowing into node 2, so that would be minus I. Then we have the current in this branch, that is plus V2 minus 0 divided by 4. Then we have the current for this branch, that would be plus V2 minus V1 divided by 10 ohms. Then we also have the current flowing out, so that would be plus 7, because it's going outward, plus 7, which is 0. So we can then move this over to this side and say that I is essentially equals to I equals V2 over 4 plus V2 minus V1 over 10 plus 7. So we can then proceed. If you call this our second equation, we can then move equation 2 into equation 1. Substitute the value of IA. Then we would have minus 2 plus V1 over 2 plus V1 minus V2 over 10 plus V2 over 4 plus V2 minus V1 over 10 plus 7 equals to 0. Okay, we have a long expression here. So what we do next is we simplify it. In order to do that, we can just simply multiply through by say 20. If we multiply through by 20, then we have minus 40 plus 10V1, okay, plus 2V1 minus 2V2 plus 5V2 plus 2V2 minus 2V1 plus 140 all equals 0. Equation can be written further as 10V1 plus 5V2 equals minus 140, and we can call this our third equation. So you can then observe this a little, and you can connect your virtual multimeter across it, and you will come to realize that V2 the voltage V2 is greater than V1 by 2 volts. That is, if you connect a multimeter across this, you get, with your negative terminal here and your positive terminal here, you get a reading of 2 volts. Therefore, we can write that V2 minus V1 equals 2, and we can call this our fourth equation. We can then proceed to solve our third and fourth equations simultaneously, and that will give us the value of our node voltages. Before we proceed to solving this simultaneously, I just noticed that this was supposed to be 100 and not 140. And then by solving this simultaneously, we would arrive at V1 equaling minus 7.33 volts, and then V2 would equal minus 5.33 volts. And that is all for today. Don't forget to like and subscribe. See you in the next video. Bye.